All right. Approaching limiting reagent problems, many people get really worried because they are some of the most difficult problems that we will need to solve in chemistry. But the good news is you're already a black belt ninja in solving limiting reagent problems, as long as we stick to amounts of material that are easy to visualize and substances that you're completely familiar with. Then you're really, really good at doing limiting reagent problems. So let me give you an example. If the recipe is that 2 pieces of bread, 2 pieces of turkey, 4 pieces of bacon, and 3 ounces of special sauce constructs the special sandwich, the bacon lovers turkey sandwich, then I can give you amounts of material: 16 pieces of bread, 12 pieces of turkey, 20 pieces of bacon, and 1 quart of special sauce, and you should be able to figure out pretty easily how many total sandwiches you could make. And then as an extra bonus, we could figure out how much of each reagent is left over. And the steps that you would use to solve this problem are exactly the same steps you would use to solve a limiting reagent problem in chemistry. It's just in switching to unfamiliar materials, sometimes we don't make the connection. So let me write this out, sort of chemistry-ize this problem, and talk about the steps you would do to solve this problem, but I'm going to write it out more in a mathematically and chemically oriented way. So the first thing is we always want a balanced chemical equation. So first thing, balanced equation, which essentially is the same as a recipe. So I'm going to chemistry-ize this recipe, and so 2 pieces of bread plus 2 pieces of turkey plus 4 pieces of bacon plus 3 ounces of special sauce gives 1 sandwich. So now I've used something that looks a little like element symbols to just say that there's amounts of each material that go into making a certain amount of product. 2 pieces of bread, 2 pieces of turkey, 4 pieces of bacon, 3 ounces of special sauce is 1 sandwich. A difference is in chemistry, the coefficients represent mole amounts. So we're going to get used to working in moles when we do chemistry problems. Here, the units are just pieces, right? Or in the case of the special sauce, ounces. So the first step, balance chemical equation or create a recipe, common to our normal practice. The second one is going to be to convert units. And normally when people do these real-life limiting reagent problems, they don't have a conversion unit step. In chemistry, you're always going to convert to moles because that's the units of the balanced chemical equation, right? So balanced chemical equation. In this case, we had 1 quart of special sauce, but the units in the equation were ounces of special sauce. So it's not written there, but it's 3 ounces. So now we have to know how many ounces in a quart, and it's 32 ounces in 1 quart. So we have 32 ounces of special sauce. And notice I'm trying to write out the amount of material and what it is so I don't lose track of what I'm thinking about. So there we have step 2. We convert the units to match the units of the equation, which in chemistry is always going to be moles. Now here's the key step for solving most of these problems is we're going to use mole ratios. Again, I'm going to use the chemistry term, mole ratios, to find out something new, or to convert a substance. Might be another way to describe it. So, for instance, we have 16 pieces of bread, right? And this is something, if you solve this problem in your head, how many sandwiches can you make with 16 pieces of bread? You probably just do an intuitive solution and don't write it out explicitly. But what we have from our recipe or a balanced chemical equation is 1 sandwich is the right amount for 2 pieces of bread. So if you have 16 pieces of bread, divide by 2 pieces of bread per sandwich, the breads cancel, you get sandwiches out, and you find out that if you used all the bread, you could make 8 sandwiches. So the amount of material you start with can be related to the amount of product you could make if this was able to be all used. If you could use all 16 pieces of bread, they would be enough to make 8 sandwiches, and use this ratio from the recipe to figure it out. 1 sandwich is 2 pieces of bread. Now the bacon, it looks like we started with a huge amount of bacon, right? So you think, how in the heck can we run out of bacon? Well, if this is the bacon lover sandwich, we use it pretty quickly. So when you do the same type of thing, 20 pieces of bacon, you get 1 sandwich. If you use 4 pieces of bacon, so the huge 20 pieces of bacon is only enough bacon to make 5 sandwiches. Now, sometimes when students are working this type of problem, they'll say, okay, we can make 8 sandwiches from the bread and 5 sandwiches from the bacon, so we can make 13 sandwiches. And if you're following me at all, you know that is ridiculous, right? Because you only have enough bread for 8 sandwiches. There's no way you can make 13. So adding these numbers up is not the right approach. What we do is we figure out what's the fewest number of sandwiches we can make given our analysis of all the different ingredients. And we pick the fewest number because at the time we've made 5 sandwiches, we've used all our bacon. So we have enough bread to make 8 sandwiches, but we ran out of bacon. And that's why bacon is the limiting reagent. And I haven't written out the explicit solution for these other things, but we have 32 ounces of special sauce, and 1 sandwich requires 3 ounces of special sauce. So whoever ordered the special sauce sort of overdid it, because we now have enough special sauce for 10 2/3 sandwiches, but we ran out of bacon at 5 sandwiches. So we hope that this keeps, so we can keep it in our inventory and use it later. And then the other ingredient was turkey. We had 12 pieces of turkey. 1 sandwich requires 2 pieces of turkey. So we can make 6 sandwiches if we could use all the turkey. So we run out of bacon when we make 5 sandwiches, and that's how many we make, given our recipe and the amount of starting material that we had. Now, the thing that will completely baffle chemistry students is how much of something will you have left over? But this is, again, fairly intuitive, that the amount you start with minus the amount you used equals the leftover, right? So let's take the bread. We start with 16 pieces of bread, and we want to know how much we used so we could figure out how much we had left over. Well, the key is we can make 5 sandwiches. And if it requires 2 pieces of bread for every 1 sandwich, again, this sort of mole ratio idea, 5 sandwiches takes 2 pieces of bread per sandwich, means we use 10 breads to make all 5 sandwiches. So then we subtract away the 10 breads we used to make the 5 sandwiches. We started with 16 breads, and we have 6 pieces of bread left over. So again, sometimes when I go and solve a problem like this, students will sort of give up on what I'm showing them halfway through because they know they can solve this already. But the message here is that when you see that they give you a recipe for construction of a product or for something that happens, and they give you amounts of material for multiple reactants, you have to figure out which one you're going to run out of first. And the steps for this: balance chemical equation, convert the units, and then use mole ratios to convert your substance so you can answer the question you're trying to answer. And in this case, we figured out how much product we could make. So how much product can you make with each reactant? And if you thoroughly understand this, the chemistry will just be an extension of this. if we use the 20 pieces of bacon, we can make 5 sandwiches with 4 bacons each. So we get all the bacon accounted for. So figuring out how much product you can make involves the mole ratio calculation for each reactant and select the product amount that's the least. And then if you want to do leftovers, again, the black belt ninja level where you're figuring out how much stuff is left over, you take how much product you made, apply the mole ratio again, find out how much stuff you used. So now I'm going to solve, next video, a chemistry problem that's similar, that was a recent quiz question, and guaranteed, if I give the sandwich problem, just about anybody can figure out with these ingredients, you can make 5 sandwiches, given the recipe. It's more intuitive. When I switch to the chemistry question, not as many people are successful, even though it's the same procedure. So I'm going to jump into that and post both of these so you can take a look at them.